Hello again. Uh, so in the first part of the lecture, we had seen uh, that in this third week, we are interested in discussing the transformation of stresses. And as a first headway into that discussion, we had very briefly recapped the concept of stress at the state of stress at a point. And the point that I had highlighted at the very end of that part one of the lecture is that the state of stress, that is the components of stress which appear at a particular point, depend very much on the choice of the coordinate axis that we use. So let's put that down in writing. This basically means that if we use different sets of coordinate axes, then the values of the various stress components will come out to be different. For various different choices of the coordinate axis, the values of the stress components will come out to be different. What we mean to say, in other words, is that suppose we have one set of coordinate axes as x, y, and z. Uh, and suppose the stress components referred to this are sigma xx, sigma yy, sigma zz, tau xy, tau yz, tau zx. And suppose we use a different set of coordinate axes, x dash, y dash, z dash, then sigma x dash, sigma y dash, sigma z dash, tau x dash, y dash, tau y dash, z dash, and tau z dash, x dash will be the stress components referred to this new set of coordinate axes. Now, in general, sigma xx will never be equal to sigma x dash, sigma yy will never be equal to sigma y dash, and so on and so forth. So again, to emphasize the point that I had been making all along, it really does depend on what coordinate axis you have chosen to work out your problem. But despite this apparent difficulty, what is true, however, and this is very, very important, and what this chapter is really all about, is that once you have the information about the stress components in one particular coordinate system, it is very much possible to mathematically obtain the stress components in another coordinate system. So if you actually know the values of sigma xx, sigma yy, sigma zz, sigma tau xy, tau yz, and tau zx, and you know what is the relationship between x dash, y dash, z dash, and x, y, and z. So perhaps this way of depicting the coordinate axis is a little bit misleading. What I mean to say is that suppose uh, it is the situation is like this, that you have x, y, and z like this, and you have your x dash, y dash, and z dash like this, then you of course know uh, what is the relative orientation of x dash with the other axis x, y, and z, what is the relative orientation of y dash with x, y, and z, and what is the relative orientation of z dash with x, y, and z. With these three pieces of information, you can actually go about finding out the values of sigma x dash, sigma y dash, sigma z dash, etc. And you don't have to measure them separately. You can actually find them mathematically. And this transformation of stress chapter is where we are going to learn how to do this. Of course, doing this three-dimensional case is a little bit challenging and beyond the scope of our first year mechanics syllabus. So what we are going to learn is to reduce the complexity of this challenge by considering a two-dimensional version of this problem. So So here in our first year, we'll focus on transformation of stress in 2D. So specifically what we are going to do, we are going to consider a state of stress where sigma xx, sigma yy, sigma xy are not zero in general, but sigma zz, sigma xz, and sigma yz, or equivalently sigma zz, tau xz, tau yz will be zero. This is very, very important. So this kind of state of stress is usually referred to as a plane stress. Is usually referred to as plane stress. So all the examples, all the explanations, all the derivations that we'll be doing will be focused on this kind of plane stress. So we no longer have to consider a three-dimensional state of stress. We no longer have to consider a three-dimensional body. Rather, we'll focus our entire attention on two-dimensional things. Uh, so what we want to do is consider a body like this. Uh, it need not be a perfect square like this. It could have a general two-dimensional shape, but for convenience, what we are doing is considering a very small area around a point in a general two-dimensional body, and we can have on our axis like this, x and y, and we know that this will be our sigma xx, this will be our sigma xy or tau xy, this will be our sigma yy, this is tau xy, this also will be sigma yy, this is sigma xx, this is tau xy, and this is tau xy also. So we are going to look at transformation of stresses from this coordinate system, from the xy coordinate system to another coordinate system, maybe an x dash y dash coordinate system, considering the same original two-dimensional body, with the understanding that we have full information about the relative orientations of x dash and y dash with the x and y coordinate axis. So that will be the discussion in the next part of our lecture.